Hello everyone, my name is Nikun Sondagar and I am from India. Completed MTech in Civil Engineering and specialization in Structural Engineering. So, today is our topic about criteria for earthquake resistance design of structure. So, today I want to discuss few important points regarding IS 1893 Part 1 2016. This is the 6th revision of IS 1893 Part 1 2016. So first of all, start with terminologies. First of all, what is the closely spaced model? Closely spaced model means the geometry similarly and torsional is unbalanced. It is also called a two vibration mode, in which the two vibration modes frequency difference is only 10% or less than the 10%. Critical damping. This is the over damping, in between the over damping and under damping. Critical damping is a damping beyond which the free vibration motion will not be oscillation. That means less of oscillations and come back into the equilibrium position. Critical damping is the damping in which the building is oscillation and come back into the normal equilibrium position. Third is a damping. The damping is the internal friction inelastic of materials, slipping, sliding, etc. in reduction the amplitude of oscillation. It is expressed as the fraction of critical damping. That means it is the reduction of amplitude of the oscillation, because we are providing some materials and due to the sliding and slipping of this, the damping value is reduced and the earthquake effect is reduced. Next is the design acceleration spectrum. Acceleration spectrum is the graph of maximum acceleration as a function of natural frequency or natural period versus specified damping ratio. Basically, design acceleration spectrum is working on single degree freedom system. The single degree freedom system means the mass is allowed to travel only along the spring elongation direction. That means the mass is direction only one direction, not more than one direction. The next point is design horizontal acceleration. It is a horizontal acceleration coefficient that shall be used for the design of structure. Okay. That means the value coefficient is 0.2 to 0.3 for the road and railway bridge, and 0.15 for the dam, and 0.15 to 0.25 for the harbor. Then next is the design horizontal force. These are the seismic force, which is standard calculated by the design of structure. For the design horizontal force, we are using different methods like equivalent statics method, dynamics method, which is useful for the calculation of design horizontal forces. Next point is ductility. Ductility, it is the capacity of the structure to undergo large inelastic deformation without the loss of the strength or stiffness. It is also called as a plastic deformation. Plastic deformation before the failure occurs. We can also call it as a ductility. What are the epicenter? Epicenter is a geographical point which is vertically exactly above the earth where earthquake is generated. It is a point of origin of the earthquake. The next is a floral response spectrum. The floral response spectrum means it is the response spectrum for the time history of the shaking generated at the floors of the structure when the structure is subjected to a earthquake ground motion at its base. It is the time history of any building which is shaking during the earthquake. This is next is importance factor. It is a factor which is useful for the design seismic force and generally depending on the uses of the building and the function of the structure. Generally it is characterized by hazardous consequence of its failure, post-processing function needed, as well as historical value or economical importance. Generally we more focusing on economical importance for the safety purpose and economical purpose. The next is the intensity of earthquake. Intensity of earthquake, that means ground shaking manifested at the place during the earthquake. That means the amount of ground shaking during the earthquake is applied on a building. The value is given in a Roman capital numbers. We can also call it the MSK. That means Mercalli scale. And generally the range is 0 to 9 and it is measured in a Richter scale factors. The next is a liquefaction. Liquefaction, that means soil loses its strength and stiffness against applied stress. That means due to the application of the stress, the soil will lose their strength and stiffness. Next is lithographical features. These are the features that reflect the nature of the geographical information on the earth's crust above the bedrock, which is characterized on the base of the structural, mineralogical component and grain size, also including color, structure, both. Next is the modal mass in mode of structure. This is the total seismic mass including in horizontal and vertical direction that is effective in the natural mode K during its oscillation of the horizontal or vertical ground motion. Then next is a modal participant factor in a mode of structure. Modal participant factor, that means this is the mode K during the vibration in the amount by which mode K is contribute overall vibration of the structure, that means overall oscillation of the structure during horizontal and vertical earthquake ground motion. That means the structure is oscillated due to the horizontal or vertical earthquake ground motion. Since the amplitude of the mode shift can be scaled arbitrarily and the value of the factor, which is generally depending on scaling used for definition model shape. Generally amplitude value is 95% should be this is the amplitude value, 95% should be taken, and this large due to the large value, strong dynamic response. They are the mode of oscillation 3.19. Then next is the mode shape coefficient. Mode shape coefficient is generally occurs when the vibration is occur. There are generally defined oscillation along the degree of freedom when the structure is oscillated in its natural mode K, and the structure with n degree of freedom passes, that means the numbers of degree, and the same way numbers of period and numbers of associated natural mode shape. There are 5 numbers of degree freedom, that means 5 number of mode shapes. The next is a natural period in the mode of oscillation. Natural period means it is the time in which the structure to complete one cycle of oscillation in its natural mode. We can also fundamental, lateral, transition, natural of oscillation. These are the mode of oscillation in which there are spatial undamped free oscillation in which all the points on the structure is oscillated harmonically at the same frequency or period. Spatial undamped condition means the no energy losses with movement, that means throughout it will be same, such that all these points reach an individual maximum response simultaneously. Then next is a peak ground acceleration, in which maximum acceleration of the ground in a given direction of the ground shaking. Here the acceleration refers to that of the horizontal motion unless specified otherwise. The next is a response reduction factor. It is generally a factor which is very useful for the calculation of actual base shear, and generally we said actual base shear which should be reduced to obtaining the design lateral force during DBE shaking, that means design base earthquake. In short form, response reduction factor is a factor which is useful to reduce the shear force, which is useful to calculate design lateral force, which you can see here, reduce the design base shear, and it generally depending on the perceived seismic damage performance of the structure, and which is a response reduction factor generally characterized by ductile or brittle formation, redundancy in the structure, or overstrength inherent in the design process. The next is a response spectrum. What is the response spectrum? These are the maximum response. These are the maximum response of a spectrum in which the idealized, these are we assume that the single degree freedom system of different natural period but having a damping shame under the action of the same frequency, that means earthquake frequency is same during the procedure. That means the response referred to here can be maximum acceleration and maximum relative velocity or maximum relative displacement. The next is a seismic mass of floor. It is the seismic weight of the floor which is divided by the acceleration due to gravity. Acceleration value generally 9.8 meters per second square. We already know the weight of the gravity. The next is the seismic mass of structure. It is the same way seismic weight of the overall structure which is divided by the acceleration due to the gravity. is a seismic weight of floor. It is the sum of dead load on the floor and the contribution of the weight of column, wall and other permanent element like beams, like furniture, story and from the story above and below, and finished and service load and appropriate amount of specific imposed load on the floor. Generally seismic weight of the floor, that means dead load, live load on the buildings. The summation of the dead load and live load. The next is a seismic weight of structure. It is the sum of the seismic weight of all the floors. That means all total weight of the seismic load on all the floors. Seismic zone factor. These are the values of the peak ground acceleration considering by the standard for the design of any structure and generally located in each seismic zone. Generally seismic zone is divided in 4 parts: zone 2, zone 3, zone 4 and zone 5. If the zone is increasing and the zone factor value will be increasing. For the zone 2 is 0.10, zone 3 is 0.16, zone 3 is 0.24 and zone 5 is 0.36. These are also given in the table. The next is a time history analysis. This is also called as a dynamic analysis of the structure, dynamic response of the structure. You can say dynamic response of the structure at each instant of the time for the specific time period. I prepare few videos for the calculation of the time history analysis and the link given in the description box, so you can view how to find the time history analysis. And for this purpose, you know the how much time the structure is resist load on the structure without the failure. These are the specific terminologies for the buildings. What is the first one? First one is base. Base is the generally level platform in which the inertia force is generated during the oscillation of the building and which is generally transferred to the ground and ground through the foundation. For building with basement, it is considered at the bottommost basement level for the building resting on. Base means the totally bottom level of the any building. If you are going down below the ground level, so bottom and the last level of the your ground floor story, you can also say cellular story. Then next is for building resting on pile foundation, it is considered to be at the top of the pile. The base, if you are considering construction of the any foundation on the pile, the base is the top level of the pile. If you are considering rough foundation, it is the top of the rough, and if you are doing footing, it is considered to be the top of the footing level. If anyway you are doing more than 2 types of footing, then means the base is considered as the bottommost level of the base of the consecutive individual foundation. That means if you are doing 2 different foundation, then bottom level of the foundation will be selected as a base. What are the base dimension? It is the dimension generally measured in a meters, which is the in the along the direction of shaking. If you are that means the shaking direction and base dimension is opposite to each other. Sorry, it's perpendicular to each other. Center of mass. Center of mass means the point through which floor of a building through which the resultant of the inertia force of the floor is considered to act during the earthquake shaking unless otherwise stated. The inertia force is considered is that association with the horizontal shaking of the building. 4.6 eccentricity. There are two types of eccentricities: designed eccentricities and static eccentricity. In the design eccentricity means it is the value of eccentricity which is useful for the floor in the calculation of torsional effect. Generally, design eccentricity is useful for the calculation of design torsional effect. The next is a static eccentricity. These are the distance between the center of mass and the center of resistance of the floor. Generally, the design eccentricity value should be taken as a 5% of the seismic building weight. The next is a design seismic base. Here, it is the horizontal lateral force in the consideration direction of the earthquake shaking that the structural shall be designing for. Design seismic base here means it is the horizontal lateral force in which the building is designed. After the amount of load, if you are increasing the load, the structure will be failed. The next is a diaphragm. Diaphragm is nothing but it is a kind of the slab. It is a horizontally or near horizontal structural system which is generally made of the reinforced concrete floor and horizontal bracing system which transmit the force by the vertical element which is connected to it. That means the diaphragm which is the slab and transfer the slab through the column and column through the footing or foundation. Height of the floor. Height of the floor is nothing but the difference in vertical elevation of the base of the building to the top of the floor. These are the height of the floor from base to its top. Height of building means from its base to top of the. These are the height of building is up to the roof level, and here is the base of the building and the top of the floor. That means individual floor, and here are the roof level. There are two important things in the height of the building. If you are excluding the height of the basement story, that means you are not considering basement story. If basement wall are connected with the ground floor slab, that means if any kind of the wall you are provided in a basement and it is connected to ground floor slab, so you can excluding the height of the basement. If any case, if necessary to including the height of the basement story, when you have to including if basement walls are not connected with the ground floor slab, that means ground floor slab and basement slab which is not connected by any kind of wall, then you have to the including the height of the basement story. Next is the horizontal bracing system. It is the horizontal truss system, and these are the functioning is same as the diaphragm. The next is a joint. Joint is very important for the structural purpose. These are the portion of the column that are common to a beam and column. That means where it is the point where the column and beam is intersect. So the point you call joint. Lateral force resisting system. That means it is the part of the structural system and consists of the all structural members that resist lateral inertia force which is induced in the building during its earthquake shaking. Moment resisting frame system means It is generally moment resisting frame considering the beam and column that resist earthquake force by its flexural, that means by beam and column. Ordinary moment resisting frame. It is a frame in which special ductile detailing should not be done as per the IS 13920 or IS 800. In the case of special moment resisting frame system, which ductile detailing should be done as per the IS code. The next is the numbers of stories. Numbers of stories means it is the number of level of a building above the base at which mass is present in sustainable amount. That means the numbers of floor you provided in a building, excluding the basement story where the basement walls are connected with the ground floor deck. We already discussed these 2 points. So next is a 4.17 principal plane axis. You can also call it the geometry of the building. If you are working with the ETAPS and StatPro, you know the geometry of the building. These are the two mutually perpendicular horizontal directions in plan of the building along which the geometry of the building is oriented. That means these are the two axes in which you draw your working plan and you can work with them. The next is the P delta effect. This is the generally second effect on the structure. This is effect on the shearing force and bending moment of the lateral force resisting element. That means that generally due to the P delta effect, the shear force and bending moment is increasing in the structural building. The next is RC structural wall. It is a wall generally designed to resist the lateral forces which is acting in its own plane. You can say these are the shearing wall or special types of shearing wall. These are the ordinary RC structural wall. This is a reinforced concrete structure in which wall designing and detailing as per the IS code, but they are not meeting at special ductile detailing as per the IS 13920. In the case of special RC structural wall, the structure you have to draw and detailing as per the ductile detailing as per the IS 13920. The next is a story. It is the space between two adjacent floors. You can also say clear height of the story. These are the soft story. The next is a soft story. Soft story is in which the lateral stiffness is less than that in the story above. That means the lateral stiffness is less than the different story. That means it is almost 70% less than the other story. Lateral stiffness means it is the ratio of the story shear to the story drift. What is the story shear and what is the story drift? I will explain in the next slide. That means next is a weak story. Weak story means the lateral strength is less than the story above. That means the strength is less than the story above, exactly above. This is the story drift. It is the relative displacement between the floors above and below the story under consideration. And the story shear is the sum of the design lateral forces at all the levels above the story under consideration. Then next is the story lateral shear strength. That means it is the total lateral strength of all the lateral force resisting elements in the planned direction of the building. Next is story lateral translation stiffness. It is the total lateral translation stiffness of all the lateral force resisting element in the story consideration. The next and the last one is the RC structural wall plan density, which is the ratio of the cross section area at the plinth level of the RC structure and the plinth of the building expressed as a percentage. 6 points general principles and design criteria. In this case I am giving you the brief introduction. Generally, ground motion is characterized by its intensity, during, frequency, content, etc. of the seismic ground, which is vibration expected at any site depending on the magnitude of earthquake. That means if the magnitude of earthquake is higher, then ground motion is basically higher. Generally, the earthquake is magnitude of earthquake is depending on the focal length, epicenter distance, and characteristic of the path through which the seismic wave travels. The response of the structure to the ground vibration generally depending on types of foundation, its materials, the form and the size and mode of the construction of the structure, and duration and characteristics of the ground motion. If the ground motion will be high, then the response of the structure will reduce. Actual force that appear on the structure during the earthquake much higher than the design force specified in the standard. That means actual force which is applied on the building is almost always higher than the design force which is specified in the standard. There are the few things should be required for the factor of safety, and all the load combinations should be applied as per the IS 1893. If when the load combination that do not containing earthquake effect, that means indicating the large demand of the combination including them. If you are not providing any earthquake effect, then you have to provide large combination, and you have to provide combination as per the ductile detailing IS 13920. Next is a design horizontal earthquake load, in which the lateral load resisting elements are oriented along the two mutually orthogonally horizontal directions. That means load is acting in the perpendicular direction to the plane in which the structural shall be designing for the effect of full design earthquake load in one direction at a time and not in the both directions simultaneously. That means you have to design any building in the one direction earthquake effect. In the second case, when lateral load resistance elements are not oriented, if your building is not oriented along the horizontal direction, then what you have to do, you have to do the designing for the simultaneous effect for full design earthquake load in one direction plus 30% of the load in a other direction. That means 100% in the x direction and 30% in the y direction. You have to do the combination of all the loads as per the IS code, where x and y is the horizontal plan direction. These are the load combination which you have to do, and you have to rechange this. You have to Lx and Ly you have to replace by Elx plus or minus 0.3 Ely and Ely plus or minus 0.3 Elx. That means your load combination is look like this. I will show you all the load combination at the end of the total load combination. The next load combination is, first of all, design vertical earthquake effect. Effect due to the vertical earthquake shaking shall be considering When you have to consider the vertical earthquake shaking, when the structure is located in zone 4 and zone 5 and the structure having a vertical or fan irregularities, then third is the structurally rest on the soft soil, then fourth is the bridge, structural has a longer span, and the structural has a large horizontal overhanging of the structural member or subsystem. In this all case you have to consider vertical earthquake shaking. In the above case, this is only for the two direction, in the x and y direction. For the three earthquake component response, we have to consider response due to each component may be combination. What you have to do, for the one direction you have to complete it, and for the second two direction you have to add multiply 0.3. that means 30% of their maximum ELX and ELY and ELZ and 100% of ELX, and these all are combination you have to do, and where x y are the plant direction and z is the vertical direction. Thus EL in the above reference, that means combination cell replacing with the ELX plus or minus 0.3 ELY and ELY plus or minus, these are the combination. So the final combination is for the three components is look like this. Remaining all the steps and design acceleration spectrum, these are the graphs, seismic zone factors, and remaining all the things we'll consider in the next part. Thank you for the watching. Like the video, share with your friends, and subscribe my channel. Thank you for the visiting. Thank you.